There are two different types of segmental retaining walls, gravity and reinforced. The wall that we are working on now is going to be reinforced. However, both walls start out the same. You have 6 inches minimum of 2A limestone base, well compacted, and then you level each block for the first course that is going to be buried. So you have a 6-inch course buried and then 6 inches of base. So the minimum you want to dig is 12 inches for a proper foundation. So in most scenarios that you see with retaining walls, they're going to show a cross section or a front view of a wall with a footer that's completely level, meaning all the blocks are on the same height, the same elevation. For this particular wall, we have a street that is on a slope, and so we need to create step-ups for the footer. So we're going to run a section of block that's level, and then when we get to a difference of 6 inches or more in height, we want to step up with another course of block and move on until we get to the next 6-inch or greater difference, and so on. In this scenario, we have a relatively flat plane in front of the wall, and so we're burying one course. The wall also is only going to be 4 feet tall, and that's completely adequate. In a situation where you have a toe slope, in other words, the wall's here and the ground slopes in front of it, or in a situation where the wall is going to be taller, 5-6 feet or more, we would want to bury at least 2 courses. So instead of just having 12 inches underground, 6 inches of base, 1 block, we would have 6 inches of base and 2 block for an 18-inch dig depth. This is a roll of GeoGrid, and you can see it's an open weave synthetic textile, and what this does is it helps to reinforce the wall into the slope. So this would be used in a wall that is over 4 foot, that's universal, and it's sometimes used in walls less than 4 feet tall when called for. If you have a wall that's supporting a load, like a really steep slope, if you have a wall that's supporting a parking area, or cars are going to be on top, traffic. If you have a really heavy stagnant load, like a really large shed or a garage on top, these are all instances where you would want to have a reinforced wall, even if it's less than 4 feet. The wall we're currently working on has a very steep slope and also the driveway up above. It is recommended by the manufacturer and by engineers to have reinforcement for a scenario like that. For this particular job, it was determined that GeoGrid reinforcement would be ideal because we're working with 2 different variables that could impact the success of the wall. We have a really steep slope, and we also have a driveway load on top of that slope. This is an instance where it's important that even if the code doesn't call for this, even though you technically don't need to have an engineered drawing for a wall under 4 foot to be compliant with your local municipality, it is really recommended to do that to make sure that your wall lasts as long as possible. GeoGrid comes in 2 forms. There is uniaxial, which means it has strength only in one direction, and then it's biaxial, so it has strength in 2 different directions. At your local supplier, it is not common to see biaxial grid. Uniaxial is what's widely available. And here's the difference, and here's why it's important to know. A lot of times I'll scour the internet and I find contractors in progress with projects and they are using GeoGrid. And for a homeowner, that can be reassuring that they are using that material. What I see a lot of times is that it's not long enough or that it's put in the wrong direction. So these pieces of grid, when they come on a roll like this, if somebody were to just kick the grid this way along the wall and then just cut off what they think they need, this uniaxial grid does not have strength this way. It's going to fail. It's not going to do its job. Whereas these sheets need to be oriented this way, rolled out from the front to the back, and then cut to length. It's more time consuming for sure, but it's the only way that you're going to get all of the usefulness out of that geogrid. The main difference between a gravity wall and a reinforced wall is how far back we dig for backfill. Backfill is that drainage stone behind the wall that separates it from the soils. Locally, we have clay and shale as our soils, and they hold moisture and they really can wreak havoc on your hardscapes. If you take a look at this particular trench, we have dug out from the face of the wall back that we can accommodate 4-foot grid lengths. And that's the minimum you would want to go. If it was a gravity wall, we would dig out about 30 inches from the face of the block back. And with that, it's the depth of the block front to back, which is 12 inches, and then 12 inches of the backfill stone, 57 limestone. And there's also a few inches to account for the batter on the wall, which means that each course of block that you go up, you will step back into the slope just a little bit with that, the positioning of the block. The fill that you want behind your base course should be impervious. It can be your soils, or you could use a 2A limestone, just something dense that won't let water pass through easily so that the water will shed and go through the face of the wall. Also important is that the outlets for your drain, which must happen at least once every 40 feet, when that outlet goes through the face of the wall, it needs to be at grade, at that finished ground height of whatever's in front of the wall. Otherwise, if it's too high, you're missing some water down below. If it's too low, then it's going to be kicking in underground. So you really have to make sure that it's just above that finished grade. There's a lot of things we could talk about. We could talk all day about walls.